Hello viewers, welcome to the lecture series of algorithms. Myself Dr. Preeti Jagwani, I am Assistant Professor in Department of Computer Science, Arabic College, University of Delhi. So today's topic is greedy technique. So basically in algorithms what we want to do, we actually want to solve a specific problem. So there is no one thumb rule which is applied to all the problems, that let's say you have a problem X, so you can go with this strategy A, or you have a problem Y, then also you can go with this particular rule and you will be able to arrive on a solution. So what I am trying to say is there will be different categories of problems in the domain of computer science, and there is not one a silver cut spoon which is applicable to for the solution of all the problems. So if nature of the problem is different, then you need to adopt a different technique to have its solution. So most commonly used techniques in the problem solving domain, basically in terms of computer science, if we talk about, so they are divide and conquer, randomized algorithms, dynamic programming, iterative techniques, and so is greedy algorithms, or greedy technique is one of these problem solving techniques. Now let me jump to what actually this greedy technique is all about, and how do we go about writing, or how do we go about having some greedy algorithms, or the algorithms which are based on greedy techniques. So in their book which is Algorithm Design by John Klinberg and Eva Tardos, they say greed is good, greed is right, and greed works. So basically they want to say that if you need to have a particular solution for a problem, that problem must fall into a specific category, then we can apply some greedy algorithms on that. So it is sometimes it is good to be greedy in terms of getting solution. So basically a greedy technique, what does it do? It chooses the available best option, or we can say it makes a locally optimal choice with the idea or with the hope that this choice will lead to a globally optimal solution. For example, I have taken one particular heuristic or one particular idea to generate a solution which is a locally optimal choice or locally optimal function, and then I will be applying this particular function recursively to the whole problem with the concept in the mind that this choice is going to lead to the globally optimal solution. For example, let me take an example of a navigation system. So for example, I need to go from a particular point A to another point B, and there are some junctions in between A1, A2, A3. So what I will be doing if I am using a greedy technique, then I will not be considering the whole solution to arrive from A to B, rather than I will be looking for the available best solution which is locally optimal. That means from point A to A1, I will be trying to reach there first with the smallest possible path, and then again that smallest possible path I will try to find for the points A1 to A2, and then from A2 to A3 I will again look for the smallest possible path, and so on and so forth. So this is basically what this is. We are looking for an optimal choice which is locally optimal, hoping for that this locally optimal will will lead to a globally optimal solution. So how are we going to define the goal in terms of greedy technique? If we talk about goal is to be formed in the form of let's say an objective function whose choice is going to be the optimal, as I have already told you. Then this objective function needs to be optimized. This may be maximization or minimization, depends upon the problem, but this objective function needs to be optimized. And a very important point about greedy algorithm is they give only one shot to compute the optimal solution. That means it never goes back and reverse the decision. Basically, considering the same example once again, let's say I am arriving to point A1, I have started from A and I have arrived to point A1, and after coming to point or after reaching to point A1, let's say I am not finding any good solution from A1 to A2, then obviously I cannot reverse my decision and go back to the original source point, which is A. So, greedy algorithms or greedy techniques never goes back and reverse the decision. So, basically in a nutshell, till now I can say at every step we need to make a choice that looks best at the particular moment and get the optimal solution of the complete problem. This is what we are trying to do. But what is the, I can say, glitch here is it always it may not produce the best optimal solution, but yes, it can be used to get an approximately optimal solution. So, a close to solution close to the optimal solution you may end up sometimes, or sometimes you may have best optimal solution, but it is not guaranteed with greedy techniques that always you are going to end up with the best optimal solution. Sometimes you can get an close to optimal solution, or we can say approximately optimal solution is also will be the result. So, now what are the pros and cons, and what are the examples of this greedy technique I am just going to cover. So, considering the pros and cons, it is always easy to coin a greedy solution. Let us say, for example, as I have already told you that I am going from A to A1, and the idea is the original problem was I need to reach to point B starting from point A, let us say in minimal amount of time. So, what is the local optimum, what is the local optimal choice will be here, that for every junction or for every intersection point, you can say you need to go for the smallest distance. So, from A to A1 I will be going to this I will be going with smallest distance, then from A1 to A2 again smallest, from A2 to A3 again smallest, and from AN minus 1 to AN, and then AN to B again smallest. So, this is what the strategy is. So, we can always say it is a easier task to coin a greedy solution, and the analysis, which is the we can say heart of algorithmic kind of problems, or the domain of algorithms is complexity analysis. So, analysis part is also very easy if we are talking about greedy algorithms. It is, yes, it is you can say it is on the easier side, but what is difficult is to prove the correctness of the algorithm. That means the algorithm or the solution which you have devised is actually correct. That particular proof is actually difficult, and as I have already told you, it may fail to find the globally optimal solution sometimes. So, advantages are it is easier to coin a greedy solution, analysis part is also easy, proving the correctness part is, yes, a bit difficult, and it sometimes fail to find the globally optimal solution. What are the coming to the next section, which says what are the main examples of this thing, your algorithms, or what are the algorithms which use this greedy technique. So, you must have heard some very famous examples like Kruskal's minimum spanning tree, Prim's minimum spanning tree, Dijkstra's shortest path algorithm or Huffman coding. All these are very well known examples which are based on the greedy technique. So, minimum spanning tree of a particular graph is covering all the vertices with minimum weight. That means the vertices are connected using edges having some weight. So, this is minimum spanning tree is obviously for a weighted graph, and we need to visit all the vertices by choosing the edges which are having minimum weight. So, this is what minimum spanning tree problem in brief is. So, Kruskal's minimum spanning tree, Prim's minimum spanning tree, Dijkstra's shortest path and Huffman coding. These are very kind of prominent or very famous examples of greedy algorithms. Let us give them a glance one by one. So, coming to Kruskal's minimum spanning tree or Kruskal's MST in short, we need to create an MST by picking edges one by one. We will pick one by one, one at a time. We will pick edges one at a time, and the greedy choice or the greedy idea here is to pick the smallest weight edge. So, that means you need to choose the edge which is having the smallest weight, but we need to be very careful about the cycles, because your choice should not end up in generating cycles, because here what are we talking about is essentially minimum spanning tree. So, as it is a tree, cycles are undesirable thing here. So, we need to be careful about the cycles. So, greedy choice is to pick the smallest weight edge that should not end up in creating a particular cycle. In this way, we will keep on using Kruskal's minimum spanning tree, or we keep on generating Kruskal's minimum spanning tree using a greedy technique. In Prim's minimum spanning tree, it is also coming by picking edges one by one, but this is going to maintain two sets of vertices, one which is already included in the minimum spanning tree and another which is not included in the minimum spanning tree. So, initially when we start, the set of the vertices included in the minimum spanning tree must be empty, and then we keep on adding the vertices into that particular set one by one until any more vertices are there. So, here the greedy choice is to pick the smallest weight edge that is going to connect the two sets. So, we have two sets, one is about the vertices already included in MST, another one is about vertices not yet included in MST. So, we need to connect these two sets using the smallest weight edge. So, this is what the greedy choice in Prim's minimum spanning tree is. So, similarly, if we talk about Dijkstra's shortest path algorithm. So, Dijkstra's shortest path tree is again built up edge by edge. It is based on the similar concept as that of Prim's algorithm, that two sets, a set of vertices already included in the tree and another set of vertices which is yet to be included, and the greedy choice is to look for a vertex which is in the set not included and has a minimum distance from the source. So, in this way Dijkstra's shortest path algorithm is again an algorithm which is based on a greedy choice. Then coming to another compression technique, a very famous compression technique which is Huffman coding. That is a lossless compression technique, and it is going to assign variable length bit codes to the different characters, and the greedy choice is to look for the least bit length code to the most frequent characters, which are the characters which are coming most frequently, and we need to compress the text, or we need to compress the data, we can say. So, which is the most frequently occurred character into within that data that must be assigned with the bit code having the least length. So that is the greedy choice. So I have just given you the 4 examples, or I can say idea of smaller idea of 4 examples, in which these examples are working on the basis of making a greedy choice in terms of a locally optimal solution. Then it is not, so greedy technique is not just about giving these solutions. Sometimes it is also used to get an approximation for very hard optimization problems. For example, traveling salesman problem. So that is a very famous problem in which a salesman has to start from one particular city and need to end at that particular city, and he or she needs to visit many cities in his path, and every city has to be visited once only, and the optimization required here is it must be done in the shortest travel path. So here the idea or the greedy idea is to pick the nearest unvisited city. Let us say the salesman is standing on the source city, and then let us say 4 cities are connected from source, and then it will pick the city which is unvisited and the nearest one, and this picking the nearest unvisited city is going to work here as a matter of greedy choice, and then it will keep on we'll keep on calling it recursively. So but here again, as I have told you, that it is an optimization problem which is pretty hard, I can say. So it doesn't always produces the best optimal solution, but it can be used to get an approximately optimal solution. So for solving the traveling salesman problem using this greedy technique may not end up in the best optimal solution, but yes, a solution which is close to optimal is definitely will definitely be there. Another point with greedy technique is you cannot guarantee that it can always be applied. It may not be applied to certain set of problems. That means the problem which we are looking for, problem whose solution we are targeting using the greedy technique, that problem must possess some specific characteristics, then only we will be able to solve that particular problem using greedy technique. So for example, there is a knapsack problem. So there are 2 versions of this knapsack problem. One is fractional knapsack problem, another one is 0-1 knapsack problem. So 0-1 knapsack problem cannot be solved using greedy strategy, but yes, fractional knapsack problem can be solved using greedy technique. I am just coming to explanation of these 2 problems in a while, but if we are talking about that this cannot be applied to all problems, and the problems on which we are going to apply greedy technique must have some specific property. So what that property is which I am talking about? So this is, the problem must have the optimal substructure. The optimal solution to the problem contained within the optimal solution to a smaller sub problem. Let us say for example, I am saying that in going from one point to another, I am taking this solution, a particular solution. So that particular solution must be contained in all other smaller sub problems. So this is what you call optimal substructure property. So problem must have the property of possessing optimal substructure, then only we will be able to apply greedy technique onto that particular problem. So coming to the examples, which is 0-1 knapsack and knapsack problem and fractional knapsack problem. So first of all, let us understand what is this knapsack problem. So knapsack here is nothing but a kind of, you can say, the literal meaning of knapsack is a bag. Assuming a thief enters a store and it is having 3 items in front of him with different weights at different value of that particular item, and his bag or his knapsack is having a specific capacity. Beyond that specific capacity, he cannot, put items into his knapsack after stealing. And the idea is the problem is what should he steal to maximize the profit, because every item is having a specific weight as well as a specific value. For example, the item number A is weighing 2 pounds and having a value of $100. Another item B is again 2 pounds having a value of $10, and third item C is having a value of 3 pounds and costing to $120, and his knapsack is only 4 pounds. So what should he steal to maximize the profit? As this is a very, I have taken a very simple example for the purpose of illustration. You can say as he must choose A and he must choose some part of C. So if I am saying some part of C, that means I am talking about fractional knapsack. So if your thief is having the liberty to pick some part of a particular item, then the problem is well known as fractional knapsack. 0-1 knapsack, as the name suggests, it's a binary kind of problem. That means your thief is not allowed to take fractions of a particular item, or it is not allowed to take a particular, or he is not allowed to steal a particular item in fractions. Either he has to pick the item, or either he has to leave the item. So that is what 0-1 knapsack problem is, and if fractional stealing is allowed, that is fractional knapsack. So within this scenario, if I am talking about the fractional knapsack and the total knapsack is having the capacity of 4 pounds, in order to maximize the profit, a thief can take a fraction of an item if allowed in the fractional knapsack problem. I can say 2 pounds of item A, which is having $100, will be taken out, and 2 pounds of item C, and that is going to make $80 is going he or she must take. So 2 pounds and 2 pounds, his whole bag is his whole knapsack is full to its own capacity, and the total value of this particular knapsack is $180. So here he or she has taken 2 pounds of item A, which is in the problem. You can see that it is completely he has taken item A, which is weighing 2 pounds, and he has taken 2/3 of item C, because item C was total having 3 pounds and $120. So if he is taking 2 parts of that particular item C, he or she will be gaining $80. So total $180 will be the value of his knapsack, and the knapsack is full to its capacity. Now coming to, so what is the greedy choice here? Greedy choice here is within the capacity limitations of the knapsack, the thief must steal the items of maximum value. That is what the greedy choice here is. And then when he is going to take another item C, again he will choose from B and C, but as he is allowed to pick some particular parts of the item, he will obviously be taking 2 pounds of item C. That means you can say 2 parts out of 3 of item C. So, this is what the fractional knapsack problem is, and the greedy choice here is within the limitations of the capacity of the knapsack, the thief will want to store the item having the maximum value. Fine. But if let us say the fractional stealing is not allowed, that means a thief can either take the item or he can leave the item, he cannot take a fraction. So, what will be the solution in this case, which is having let us say A, item A 2 pounds $100, item B 2 pounds $10, item C with the weight 3 pounds $120. So, here the thief is going to have a solution which is picking the item C, the weight is 3 pounds and the value is $120. So, but this 0-1 knapsack problem solution is not the solution of a greedy technique. No greedy choice or no greedy technique has been applied here. So, I can say that greedy strategy or greedy algorithms may or may not be applied to the particular problem. If the problems are if the problem is possessing the property of optimal substructure, then only you can apply greedy, but 0-1 knapsack problem is lacking somewhere. So, this solution which I have already told you, that 3 pounds of item C worth $120 is not a solution which is which we got from the greedy algorithm, it is some other dynamic programming algorithm. So, basically this is the I can say one restriction of the greedy technique is one, you need to check the problem whether it can be applied or not, and another idea is to see the thing that whether it is going to give you a globally optimal solution or not, or we can say whether it is going to give you the best optimal solution, or you need to be satisfied with the I can say an approximately optimal solution. But in computer science this is a general idea that many times we are not looking for global optimal solutions. Many of the users or many of the applications work really well with approximately optimal solutions. So, I can say that greedy technique is very important technique or very important paradigm of problem solving under the algorithms or in the algorithms domain. So, in order to sum up the lecture, what all we have covered is in short we have seen what are the common techniques which can be used for problem solving, and then we drill down our focus to greedy techniques. So, what actually greedy technique is, how it can be applied, and on what kind of problems we can apply greedy technique, what are the common examples like of the greed on which greedy technique is being applied, what are the famous solutions which includes Kruskal's minimum spanning tree, Prim's minimum spanning tree, Dijkstra's shortest path algorithm, Huffman coding, and there are many more algorithms. This list is actually not the list of 4 examples is obviously not the exclusive list, and then we have seen that where this particular greedy algorithm can be applied and where this greedy algorithm can not be applied. So, we have just seen one example that in case of fractional knapsack problem greedy technique can be applied, but in case of 0-1 knapsack problem the same greedy technique or any greedy technique cannot be applied. So, this is what is all about how we can, or more specifically where we can apply greedy techniques. Hope you have enjoyed the lecture. Thank you for a patient hearing.